What is Java? Java is a high-level, class-based, object-oriented programming language that is designed to have as few implementation dependencies as possible. It is a general-purpose programming language intended to let application developers write once, run anywhere, WARA, meaning that compiled Java code can run on all platforms that support Java without the need for recompilation. This simple code snippet demonstrates a base structure of a Java program. It defines a class named Hello World. Inside the class, there's the main method, which is the entry point of any Java application. In the main method, there's a single line of code that prints the text Hello World to the console. The system.out.println command is used to output text in Java. When the program is run, it prints out Hello World and terminates. Java history and versioning. Java is a widely used programming language that was first released by Sun Microsystems in 1995. Over time, Java has evolved through several versions, offering new features and optimizations with each release. Java was created with the philosophy of write once, run anywhere, meaning that Java applications can be run on any device that has the Java Virtual Machine, JVM. The first public implementation was Java 1.0 in 1996. Since then, there have been numerous versions like 1.1 in 1997, and significant releases like Java 2, J2SE 1.2 in 1998, Java 5, 1.5 in 2004, Java 8 in 2014, and the latest as of my knowledge cutoff in 2023, Java 16 and 17. Each version has brought new language features, API enhancements, performance improvements, security updates, and bug fixes. JDK, JRE, and JVM. Java Development Kit, JDK, Java Runtime Environment, JRE, and Java Virtual Machine, JVM, are essential components of the Java ecosystem. JDK is the complete software development kit required to develop Java applications. JRE is the package required to run Java applications, and JVM is the engine that runs Java bytecode. Let's write a simple Java program to illustrate their use. The code represents a basic Java program. JDK compiles this code into bytecode.class files, which can then run on JVM. JVM interprets this bytecode into machine code, making Java platform independent. JRE contains JVM and other libraries needed at runtime. Without these three components, developing and executing a Java program would not be possible. First Java program. The first Java program typically involves writing a simple program that prints a message to the console. This is often the Hello World program, a tradition in learning programming languages as a first step. To write and execute this, you need to have the Java Development Kit, JDK, installed on your computer. In the code, public class Hello World defines a class named Hello World. Public static void main string args is the entry point of a Java application. A Java application starts executing from the main method. System.out.println Hello World is a statement that prints the string Hello World to the console. Each line performs a specific task in the program. Curly braces define a block of code, and lines end with a semicolon. Syntax and program structure. Java syntax refers to the set of rules that define how a Java program is written and interpreted. A program's structure is the way its code is organized, including the use of classes, methods, and variables. In the provided code snippet, public class Hello World defines a class named Hello World. The public static void main string args method is the entry point of a Java application where the program starts executing. System.out.println Hello World is a statement that prints the text Hello World to the console. Each line and punctuation is part of Java's syntax, which must be precise to compile and run successfully. Basic program elements: classes, methods, fields. In Java, a class is a blueprint for creating objects. A method is a block of code that performs a specific task, and a field is a variable within a class that stores data. Here is a simple example of how they are defined and used within a program. The car class encapsulates the data and methods related to cars. The brand field holds the brand name of the car. The constructor car_string_brand initializes the brand when a new object is created. The displayBrand method prints out the car's brand. In main, the main method is the entry point of the program, where a new car object is instantiated with Toyota as the brand, and the brand is displayed by calling mycar.displayBrand. Comments in Java. Comments in Java are annotations in the source code that are ignored by the compiler. They are used to describe the purpose of certain code blocks to make the code more understandable for humans. In the provided code, there are three types of comments used in Java: single-line comments, multi-line comments, and Java.comments. comments. Single-line comments start with slash and extend to the end of the line. Multi-line comments are enclosed within and step and can span multiple lines. Java.comments are multi-line comments that start with and end with, used for generating formal documentation. Data types, primitive and reference. In Java, every variable has a data type which tells us the size and nature of the variable's value. There are two categories of data types: primitive and reference. Primitive data types include byte, short, int, long, float, double, boolean, and char. They hold their values directly and are not objects. Reference data types, on the other hand, are used to refer to objects. They include classes, interfaces, and arrays. Here is an example showing the declaration of each type. In the code, byte value through char value demonstrate primitive data type initializations. The lowercase naming indicates that they are not objects but store literal values. On the other hand, string value represents a reference data type, since string is a class and holds a reference to an object rather than the data itself. Notice the L and F suffixes indicate that literals are long and float types respectively. Reference types like string are capitalized as per Java naming conventions, suggesting they refer to a class or an object. Variables. In Java, a variable is a container that holds data which can be changed during the execution of a program. Variables have a data type that dictates what kind of data it can hold, such as numbers, text, etc. This code snippet declares three variables: an int variable, age, with a value of 30, a string variable, name, with a value Alice, and a Boolean variable, isJavaFun, with a value of true. The int data type is for integers, string is for text, and Boolean is for true-false values. Operators and expressions. Operators in Java are special symbols that perform specific operations on 1, 2, or 3 operands, and then return a result. An expression is a construct made up of variables, operators, and method invocations, which are constructed according to the syntax of the language that evaluates to a single value. In this code snippet, plus and nanas are arithmetic operators used to calculate the sum and difference of A and B. The urats is a relational operator that compares A and B, resulting in a Boolean value true if A is greater than B and false otherwise. The equals operator is used for assignment, that is, setting the variables sum, difference, and is greater to the results of the expressions on the right side. Control flow statements. If-else, switch case. The if-else statement in Java is used to test conditions and execute different code paths based on whether the condition is true or false. The code checks if the variable number is greater than 0. If the condition evaluates to true, it prints the number is positive. Otherwise, it prints the number is not positive. Loops for while, do while. Loops in Java are used to execute a block of code multiple times, which is useful for tasks that require repetition. There are three main types of loops: for, while, and do while. The for loop is typically used when the number of iterations is known beforehand. The while loop is used when the iteration should continue until a certain condition becomes false. The do while loop is similar to the while loop, but it executes the block of code once before checking the condition. The provided code block demonstrates the three types of loops. The for loop prints numbers 0 to 9. It initializes I to 0, continues as long as I is less than 10, and increments I by 1 each time. The while loop prints numbers 10 to 1. It continues to loop as long as j is greater than 0, with j decreasing by 1 each iteration. The do while loop prints numbers 0 to 4. It will execute once before checking if k is less than 5, guaranteeing at least one execution, and increments k each time. Break and continue statements. In Java, break is used to exit a loop prematurely, regardless of the loop's condition. It's usually used in conditional statements inside the loop to break out of the loop based on some condition. On the other hand, continue skips the current iteration and proceeds to the next iteration of the loop. This is used when you want to ignore specific conditions within your loop, but continue looping over the rest of the items. The code demonstrates the use of break and continue inside a for loop that iterates from 0 to 9. When I equals 5, the break statement executes, causing the loop to exit, and no further iterations occur. The continue is placed inside a conditional check for odd numbers, I%2 equals 0. When this condition is true, the loop skips the current iteration, thus the print statement is not executed for odd values of I. As a result, the output will be the even numbers from 0 to 4. Block scope. In Java, block scope refers to the visibility of variables defined within a set of curly braces, a block. Variables declared inside a block are not accessible outside that block. This helps manage which parts of a program can see or modify these variables. In the provided code, we declare a variable outer variable inside the main method, which is accessible throughout the method. Inside the curly braces, we create a new block scope and declare inner variable. This variable is only accessible within these braces, so attempting to print inner variable outside the block results in a compilation error. OOP concepts: abstraction, encapsulation, inheritance, polymorphism. Abstraction in Java is the concept of hiding the complex reality while exposing only the necessary parts. It involves creating classes that represent abstract entities that can perform work, show details, and change state, but the complexity is hidden inside methods that are exposed via a simplified interface. Here, vehicle is an abstract class that defines an abstract method's start. Car is a concrete class that extends vehicle and provides the implementation for the start method. Users of the car class need only know how to call the start method, not the details of how it starts the car. Classes and objects. In Java, classes are the blueprints for creating objects. A class defines the structure and behaviors of all entities of a given type. An object is an instance of a class, containing actual values for the entity it represents. The code defines a bicycle class with instance variables gear and speed. It also has methods to change these values, change gear, speed up, and apply brakes. The main class demonstrates creating a bicycle object, bike1, manipulating its state with class methods, and then outputting the current gear and speed. Constructors. In Java, a constructor is a special type of method that is called when an object is instantiated. Constructors have the same name as the class and do not have a return type. They are used to set up the initial state of an object by initializing instance variables. There can be more than one constructor in a class, which is known as constructor overloading. The car class declares two constructors. The first constructor is a default constructor with no parameters, setting default values for the model and year. The second constructor is parameterized, taking a string and an int to set the model and year of the car instance. In the main class, we instantiate two car objects, one using the default constructor and one using the parameterized constructor. The display method is called on both to output the car details. Static keyword, methods and variables. The static keyword in Java is used to indicate that a particular member, variable or method, belongs to a type itself, rather than to instances of that type. This means that a static member is shared across all instances of the class. Static methods can be called without creating an instance of the class. Static variables are also known as static members or class variables. In the provided code, we have a class calculator with two static methods, add and subtract. These methods are called from the main method without creating an instance of calculator. Since add and subtract are static, they belong to the class calculator itself. When we call calculator.add53, we're invoking the add method directly on the class, not on an instance of the class. The same goes for calculator.subtract53. The static methods operate on the arguments passed to them and return the results, which are then printed out in the main method. Access modifiers, private, public, protected. Access modifiers in Java define the accessibility or scope of a class, method, or variable. Java has 4 access modifiers: public, private, protected, and the default, no modifier. Public means the member is accessible from any other class. Private means it is accessible only within its own class. Protected means it is accessible within its own package and by subclasses, and no modifier, default, means it is accessible only within its own package. In the provided code, public var can be accessed from any class, protected var can be accessed from any class in the same package and any subclass, and private var can only be accessed within the access example class. The print variables method is public and can be used to print the values of all three variables, demonstrating their different access levels. Method overloading. Method overloading in Java is a feature that allows a class to have more than one method with the same name, as long as their parameter lists are different. It's a way to create methods that perform similar tasks but with different inputs. In this example, the math operations class has three different multiply methods, each with different parameters. The first method takes 2 integer parameters, the second takes 3 integers, and the third accepts 2 doubles. At compile time, Java determines which method to call based on the method's signature, method name plus parameter list. This design allows the same method name to be used contextually, promoting code readability and reuse. Inheritance basics. Inheritance is a fundamental concept in object-oriented programming that allows one class, the subclass or derived class, to inherit fields and methods from another class, the superclass or base class. The key benefit is reusability and extension of code without modifying the existing class. In this code, the vehicle class is a base class which has a field brand and a method honk. The car class is a subclass which extends vehicle, inheriting its attributes and methods. The car class also defines its own field model name and a method display model. In the main class, when an object of car is created, we can call the inherited method honk, as well as the method displayModel that belongs to car itself. This illustrates basic inheritance, where car inherits from vehicle and gains its properties and behaviors. Method overriding. Method overriding in Java is a feature that allows a subclass to provide a specific implementation for a method that is already defined in its superclass. This is used when a subclass needs to modify the behavior of a method based on the subclass's specific needs. In this example, class dog extends class animal. Both classes have a method named speak. The dog class overrides the speak method of its superclass animal. When speak is called on an object of dog, the overridden method in dog is executed, outputting the dog barks. The @override annotation is used to indicate that a method is overridden and helps prevent errors, such as misspelling the method name or not correctly matching the parameters. Abstract classes and interfaces. Abstract classes are classes that cannot be instantiated on their own and are typically used as base classes. They may contain abstract methods, which are methods without a body, that must be implemented by derived non-abstract classes. In the code, animal is an abstract class with the abstract method makeSound. Two concrete classes, dog and cat, extend animal and provide their versions of the makeSound method. The dog class's implementation prints bark, while the cat class's implementation prints meow. Final keyword. In Java, the final keyword is used to denote constants and to prevent overriding or inheritance. It can be applied to variables, methods, and classes. In the code, pi is a constant final variable that cannot be reassigned. The showValue method is final, which stops it from being overridden in any subclass. The extended example class, which tries to override showValue, would result in a compilation error, which is commented out to prevent the error from happening in this example. Arrays. In Java, an array is a container object that holds a fixed number of values of a single type. The length of an array is established when the array is created and cannot be changed. Each item in an array is called an element, and each element is accessed by its numerical index. Below is an example of how to declare, instantiate, and initialize an array of integers in Java, as well as how to access elements and loop through the array. The given code demonstrates the basics of using an array in Java. We first declare an integer array named numbers and allocate space for 5 integers. The array is then initialized with values 2, 4, 6, 8, and 10. An element is accessed using its index, where the index starts at 0. We print the third element with index 2 of the array. Following that, A for loop is used to iterate over the entire array by utilizing the array's length property, printing each element to the console. Collection Framework Overview. In Java, the collection framework provides a set of interfaces and classes for storing and manipulating groups of data as objects. It includes various data structures like lists, sets, and maps, which can be used for various purposes like searching, sorting, insertion, manipulation, and deletion of data. The code snippet imports the required classes from the Java collection framework. An array list, a type of list, hash set, a type of set, and hash map, a type of map, are instantiated to demonstrate basic operations. The list supports duplicate elements, set contains unique elements, and map holds key-value pairs. Java is added to the list, collections to the set, and a key-value pair, key-value, to the map, with each collection type outputting its contents when printed. List interface, array list, linked list. The list interface is a part of the Java collections framework and is a child interface of collection. It represents an ordered collection, also known as a sequence, and allows duplicate elements. Two commonly used classes that implement the list interface are ArrayList and LinkedList. ArrayList is a resizable array implementation of the list interface, while LinkedList is a doubly linked list implementation. Both have their own advantages in terms of performance for different operations. In this code example, we import the necessary classes and declare a class named ListExamples. Inside the main method, we create an instance of ArrayList and LinkedList, each holding string types. We then add a couple of fruit names to both lists using the add method, which appends the elements at the end of each list. Finally, we print out the contents of both the ArrayList and LinkedList. This demonstrates basic list operations and how both ArrayList and LinkedList preserve the insertion order. Set interface, hash set, linked hash set, tree set. In Java, the set interface is part of the collections framework and represents a collection that contains no duplicate elements. There are several implementations of the set interface, including hash set, linked hash set, and tree set. Hash set stores elements in a hash table, offering fast access and insertion. Linked hash set maintains a linked list of the entries in the set, preserving the order of insertion. Tree set stores its elements in a red-black tree, which means that it maintains the elements in sorted order. The provided code example demonstrates the use of three set implementations: hash set, linked hash set, and set. A set can only contain unique elements, and this code snippet adds elements in reverse order to showcase how each implementation deals with ordering. Hash set does not retain any order. Linked hash set retains the order of insertion, and you can observe this when the elements are printed. Tree set automatically arranges the elements in their natural order, ascending in this case, as can be seen in the printed output. Map interface, hash map, linked hash map, tree map. The map interface in Java represents a collection that maps keys to values, meaning each key can be associated with exactly one value. This interface is implemented by various classes, including hash map, linked hash map, and tree map. In this code, three map implementations are demonstrated: hash map, linked hash map, and tree map. Hash map offers no guarantees on the iteration order. Linked hash map maintains a linked list of the entries in the map, which allows for insertion order iteration. Tree map guarantees that entries will be sorted by the natural ordering of the keys, or by a comparator provided at map creation time. The maps are populated with integer keys and string values to illustrate storing and retrieving data. Stack and queue. A stack is a linear data structure which follows a particular order in which the operations are performed. The order may be LIFO, last in first out, or FILO, first in last out. Here we'll look at the stack implementation in Java using the stack class, which provides basic operations like push, pop, peek, and isEmpty. In the provided code, we import the java.util stack class and create a stack instance for integers. We then push numbers 1, 2, and 3 onto the stack. The pop method removes the top element of the stack and returns it, which is 3. The peek method returns the top element without removing it from the stack, which is 2 after the pop. Finally, isEmpty checks if the stack is empty, returning false in this case, as there are still elements in the stack. Iterators. In Java, Iterators are used to iterate over collections such as lists, sets, and queues. The iterator interface provides methods to navigate through a collection and to modify the collection during iteration. It's a universal way of accessing elements in a collection, one by one, without exposing the underlying representation of the collection itself. In the provided code example, we have an array list called numbers that contains integers from 1 to 5. We obtain an iterator for the list using numbers.iterator. We then use a while loop to iterate through the collection, checking if a next element is available with it.hasNext. If it is, we retrieve the next element with itNext. If the retrieved number is odd, number sent2 equals 0, we remove it from the collection using itRemove. Finally, the modified list is printed out, showing only the even numbers. Comparators and comparables. In Java, comparators and comparables are used to define a natural ordering for objects, or a specific order defined by a separate class. Comparable is an interface defining a single method compare2, used to order the objects of the implementing class. Comparator, on the other hand, is an interface used to create an external control over the sort order of a collection of objects. The comparable interface requires a class to implement the compare2 method. This method compares this object to another object to determine their natural ordering. On the other hand, the comparator interface requires implementing the compare method, which takes two different objects of the same type and compares them, allowing for custom order without the need to modify the object's class. Let's use a simple example compiling both comparable and comparator to demonstrate their use. Exception hierarchy. In Java, exceptions are objects representing errors or issues that disrupt the normal flow of the program. Java uses a class hierarchy to categorize different types of exceptions. At the top of this hierarchy is the throwable class, which is subdivided into error, representing serious issues that a reasonable application should not try to catch, and exception, which are issues that application might want to handle. In the provided code snippet, we demonstrate handling an exception within the Java exception hierarchy. We have the main method inside the class exception hierarchy example. Within a try block, we deliberately throw a null pointer exception, which is a subclass of runtime exception, itself a subclass of exception. This exception is then caught by the catch block that catches any exception. ex.getMessage is called to retrieve the error message from the exception object, and it is then printed to the console. This code exemplifies how to catch and handle a specific exception in Java. Try, catch, finally blocks. In Java, exceptions are used to handle errors gracefully. A try block contains code that might throw an exception, while catch blocks are used to handle the exception. The finally block contains code that is always executed after the try and catch blocks, regardless of whether an exception occurred. In the provided code, the division by 0 within the try block will throw an arithmetic exception. The catch block catches this exception and prints an error message. The finally block then executes, printing a statement to the console. The finally block executes regardless of whether an exception was caught, ensuring that necessary cleanup or other essential operations are performed. Creating custom exceptions. In Java, custom exceptions allow developers to create specific error types for various cases that standard exceptions don't cover, providing more meaningful error messages and better control over error handling. The provided code defines a new class, myCustomException, which extends the Java built-in exception class. By doing this, we create a new type of exception. The constructor of myCustomException accepts a string that represents the error message, which is passed to the superclass exception constructor using superMessage. To use this custom exception, you instantiate it with a message and throw it using the throw keyword, as shown in the usage example. Throwable class methods. In Java, throwable is the superclass of all errors and exceptions in the language. Here are some common methods of the throwable class. In this code, we demonstrate the use of three throwable class methods: getMessage, toString, and printStackTrace. getMessage returns the detailed message string of the throwable. toString returns a short description of the throwable containing the throwable's class name and the detailed message. printStackTrace prints the throwable along with its stack trace to the standard error stream. These methods are helpful for debugging and providing information about errors and exceptions that occur during runtime. Checked versus unchecked exceptions. In Java, exceptions are used for error handling and are categorized into checked and unchecked exceptions. Checked exceptions must be either caught or declared in the method's throws clause. Unchecked exceptions, also known as runtime exceptions, do not need to be explicitly handled. In the provided code, a file reader is created, which may throw a file not found exception, a checked exception. This exception must be caught or declared to be thrown. The file not found exception is caught in a try-catch block, which is required for it to compile. On the other hand, an arithmetic exception may occur when dividing by 0. This is an unchecked exception, which the Java compiler does not require to be caught or declared, thus there's no try-catch block surrounding the division operation. Throws keyword. In Java, the throws keyword is used to indicate that a method may potentially throw an exception that must be handled by the calling function or further propagated. If the exception that might be thrown is a checked exception, it must be declared with throws. This keyword helps to make exception handling transparent. In the provided code snippet, we define a method named readFile that takes in a string parameter called filename. This method is declared with throws IO exception, which means that it might throw an IO exception. Hence, any calling method must handle this exception by either catching it or further declaring it with throws IO exception in its own method signature. Not handling this in the calling method would result in a compile time error. Exception best practices. Handling exceptions effectively is crucial for building robust applications in Java. Below are some of the best practices you should follow when working with exceptions. This code demonstrates the structure of a try-catch finally block in Java. It is important to catch the most specific exceptions first and then catch broader exceptions later. Always clean up resources in the finally block to avoid resource leaks, even if an exception occurs. Avoid catching generic throwable or exception unless necessary, and never use empty catch blocks as they hide errors. Java I/O streams. Java I/O streams are used to perform input and output of data in Java. They are used to read from and write to data destinations like files, networks, or other sources and destinations. Java provides a rich set of I/O streams, which are organized into two main hierarchies: the input stream, output stream classes for binary data, and the reader-writer classes for character data. The code example demonstrates how to copy a file in Java using byte streams. It uses file input stream to read bytes from input.txt and file output stream to write bytes to output.txt. The try with resources statement ensures that both streams are closed automatically after the operation is finished. The read method reads 1 byte at a time from the input stream and returns -1 when the end of the file is reached. Each byte read is immediately written to the output stream with write. Reader and writer classes. In Java, reader and writer are abstract classes for reading character-based data and writing characters, respectively. They are part of the java.io package. The code demonstrates the use of file reader and file writer classes, which are concrete implementations of reader and writer, respectively. The file reader is used to read from a file named input.txt, 1 character at a time. The file writer is used to write characters to output.txt. The try with resources statement ensures that both the file reader and file writer are closed after the block is executed. Inside the try block, we read characters until the end of the file is reached, indicated by read returning -1. Each character read is then written to the output file. Input stream and output stream classes. In Java, input stream and output stream are abstract classes that represent the input and output streams of bytes. Input stream is used for reading bytes from a source, while output stream is for writing bytes to a destination. The provided code demonstrates the use of file input stream and file output stream, which are concrete implementations of input stream and output stream, respectively. A file named input.txt is read byte by byte using the read method of file input stream. Each byte read is then written to output.txt using the write method of file output stream. Both input and output streams are enclosed within a try with resources statement, ensuring that they are closed automatically at the end of the block, which helps to prevent resource leaks. File handling. In Java, file handling is an integral part of I/O, input-output, that allows us to read from and write to files on the file system. Java provides several classes and methods in the java.io package for handling files, such as file, file reader, file writer, and more. The code above uses the file class to represent a file named example.txt. The createNewFile method is called on the file object to create a new file if it does not already exist. If the file is created successfully, it prints a confirmation message. Otherwise, it prints a message that the file already exists. All of this is wrapped in a try-catch block to handle any I/O exceptions that may occur if there is an issue accessing the file system or creating the file. Serialization and deserialization. Serialization is the process of converting an object into a byte stream, allowing it to be written to a file, sent over a network, or stored in a database. Deserialization is the reverse process where the byte stream is converted back into a replica of the original object. The code defines a class serialization demo that is marked with the serializable interface, allowing Java's serialization mechanism to convert instances of the class into a byte stream. The class includes a serial version UID, which is a unique identifier that aids in verifying the sender and receiver of a serialized object are compatible. The main method creates an instance of serialization demo, then serializes it to a file named objectdata.ser. Subsequently, it deserializes the object from the file and prints the object's data to confirm the process was successful. Try with resources statement. The try with resources statement is a try statement that declares one or more resources. A resource is an object that must be closed after the program is finished with it. The try with resources statement ensures that each resource is closed at the end of the statement execution. In the provided code snippet, a buffered reader is declared within the parentheses of the try statement. This is the resource that will be automatically closed at the end of the try block. The buffered reader reads text from the file file.txt. It's important to note that the resource must implement the auto-closable or closable interface, which buffered reader does. The catch block catches I/O exception, which might be thrown if there's an issue accessing or reading the file. Since Java 7, this approach is preferable to the older try-catch finally blocks for managing resources because it makes the code cleaner and more readable. Buffered streams. In Java I/O, a buffered stream adds functionality to another input or output stream, the underlying stream, by reducing the number of interactions with the storage medium through the use of a temporary in-memory buffer. This can greatly improve the performance of I/O operations, especially for reading from and writing to disk. In the provided code, we first create a file output stream to write to a file named output.txt. We then wrap it in a buffered output stream to enhance performance. Characters J, A, V, A are subsequently written into the buffered stream. The flush method is called to ensure all data in the buffer is written to disk before we close the stream. Finally, the streams are closed in the reverse order they were opened to release system resources. File reader and file writer. File reader and file writer are classes in Java's I/O input-output API that enable reading and writing to files character by character. They are often used for text files. In the code, file writer is used to create and write characters to output.txt. File reader reads characters from input.txt. The try with resources statement ensures both reader and writer are automatically closed. The read method reads one character at a time, returning -1 at the end of the file, which breaks the loop. Captured characters are written to output.txt until the end of the input file is reached. I/O exception is caught to handle any I/O errors. Scanning and formatting. In Java, scanners are used to parse primitive types and strings using regular expressions, whereas formatting allows us to convert data into a formatted string. The code sets up a scanner to parse a string containing different data types. NextInt reads an integer, NextDouble reads a double, and next reads a string. The system.outprintf method is used to format and output the variables, with cent_d as a placeholder for integer, cent_pot2f for a formatted double with 2 decimal places, and cent_s for a string. The scanner is then closed to prevent resource leaks. Introduction to generics. Generics provide a way to create classes, interfaces, and methods with a placeholder for a type. They enable types, classes, and interfaces to be parameters when defining classes, interfaces, and methods. In the provided code snippet, box is a generic class with a type parameter t, which is a placeholder that will be replaced by an actual type when an object of the class is instantiated. The set method accepts a parameter of type t, and the get method returns an object of type t. By using generics, the box class can be reused for different types, increasing code reusability and type safety. Generic types and methods. Generic types are a way to parameterize classes, interfaces, and methods so that they can operate on various data types while providing compile-time type safety. A generic type is specified by a type parameter enclosed in angle brackets. Here, box is a generic class that can hold any type of object specified at the time of instantiation. The type parameter t represents the type of object the class will hold. The set method assigns an object of type t to t, and the get method returns it. The actual data type to replace t is determined when an object of box is created. Type parameters. In Java, type parameters allow you to create classes, interfaces, and methods that can operate on various data types while providing compile-time type safety. This feature enables you to write flexible, reusable code. Here's a basic example of a generic class with a type parameter. The class box is defined with a single type parameter t. The angle brackets at t signify that t is a placeholder for the actual type that will be used when an instance of box is created. Methods set and get use the type parameter to define their argument and return types, respectively. When creating an instance of box, you specify the actual type to use in place of t, like box integer or box string. This tells the compiler what type of objects the box will hold, and it ensures type safety at compile time, preventing runtime typecasting errors. Bounding type parameters. In Java generics, bounding type parameters allow us to restrict the types that can be used as arguments in a parameterized type. For example, you can limit the type parameter to a certain class or to any subclass of a particular class, or what interfaces it must implement. In the given code, box is a generic class that has a type parameter t. The expression t extends number is a bounded type parameter. It specifies that the type parameter t can only be substituted by number or any of its subclasses, e.g. integer, double. Instead of just number, it can also be any class that extends another class, or any type that implements a particular interface. Generic wildcards. In Java generics, wildcards allow a method to be parameterized with unknown generic types while still enforcing type safety. The wildcard is represented by the question mark and can be bounded or unbounded. Unbounded wildcards represent any type, while bounded wildcards are either upper bounded, it extends type to allow any subtype of type, or lower bounded, chose supertype, to allow type and its supertypes. The function printList takes a list with an unknown generic type as an argument, represented by the wildcard. This way, it can accept a list of any type, list integer, list string, etc., and it iterates over the list printing each element. The elements are accessed as objects since the exact type parameter is unknown, ensuring type safety while providing flexibility. Type erasure. Type erasure is a process used by the Java compiler to enforce type constraints only at compile time and to erase the generic type information afterwards. This means that the compiled code is compatible with older versions of Java that do not support generics. Let's consider an example to understand how type erasure works in Java. In the above code, we have a generic class box with a type parameter t. When the Java compiler compiles this class, it removes all information related to type parameters and type arguments. This means that t is replaced with its bounded type or object if no bounded type is specified. Hence, in runtime, instances of box integer and box string will be treated as plain box objects. The getters and setters will use casts to ensure type correctness, but the bytecode will not contain generic type information. Generic restrictions. You cannot create an instance of a type parameter, This restriction exists because the compiler erases all type parameters in generic code, so it cannot know what type to instantiate. In the above code, attempting to create an instance of t using new t will result in a compilation error. This is because at runtime, t could be any type, and the Java compiler erases generic type information during compilation, type erasure. Therefore, the exact type that t represents is not known at runtime, making instantiation impossible. Processes and threads. In Java, process is a unit of execution that has its own memory space, whereas a thread is a separate path of execution within a process. A Java program runs in its own process, and threads can be used to perform tasks simultaneously within that program. Threads share the same process's resources, but execute independently. The code defines a class helloThread that extends the thread class. The run method is overridden to provide the code that the thread will execute. When the start method is called on a helloThread instance, the Java virtual machine calls the run method in a new thread. This allows hello from a thread to be printed concurrently with the main thread of execution. Creating threads, thread class, runnable interface. In Java, threads can be created by two main mechanisms: inheriting from the thread class or implementing the runnable interface. Creating a thread by extending the thread class is straightforward but limits inheritance, while implementing the runnable interface offers more flexibility and allows class to extend another class. The code snippet provides two examples of thread creation. The first uses the thread class through inheritance. MyThread extends thread and overrides its run method to define the task. The main method then creates an instance of MyThread and calls start to initiate the thread. The second example uses the runnable interface. It creates an anonymous runnable and passes it to a new thread object. The run method of the runnable is overridden to define its task. MyRunnableThread.start initiates the second thread. Both threads will execute concurrently with the main thread. Thread lifecycle. In Java, a thread goes through various states from its creation until its termination. Understanding the lifecycle of a thread is crucial for implementing concurrency correctly. The main states are new, runnable, blocked, waiting, timed waiting, and terminated. The code defines a class threadExample which extends thread. The run method is overridden with a loop that makes the thread sleep for 1 second between iterations, simulating work. In the main method, a new instance of threadExample is created, and the state of the thread is printed before and after calling start, which moves it from new to runnable. The main thread then sleeps briefly and prints the state of threadExample, which may be timed or waiting if it's sleeping, or runnable if it's executing. After calling join, the main thread waits for threadExample to finish, printing its state as terminated at the end. Synchronization. Synchronization in Java is a critical concept when dealing with concurrency. It is used to control access to shared resources by multiple threads to avoid data inconsistency or corruption. Java provides synchronized methods and blocks to perform synchronization. In this code, we define a class counter that has a private variable count. The method increment is marked as synchronized, which means that only one thread at a time can execute increment. This prevents other threads from calling increment on the same counter instance until the first thread exits the method, thus ensuring thread safety of the count variable. Inter-thread communication. Inter-thread communication in Java is crucial when threads have a producer-consumer relationship or when proper coordination is needed between threads. It is achieved through methods such as wait, notify, and notify all that are part of the object class. This code snippet is an example of a shared resource class where the getData and setData methods are used for inter-thread communication. The getData method waits using wait when ready is false, meaning data is not yet produced. After consuming the data, it sets ready to false and calls notify all to wake up any waiting threads. Conversely, the setData method waits if ready is true, since this implies that the previously set data has not been consumed yet. Once the new data is set, it flags ready as true, and notify all is called to notify the consumer threads that new data is available. Proper synchronization is maintained by declaring methods synchronized, ensuring that only one thread can execute them at a time. Concurrent collections. Concurrent collections are thread-safe versions of standard collections like lists, sets, and maps. They're designed to provide better scalability when multiple threads access a collection concurrently. Java's util.concurrent package provides several concurrent collection classes like concurrent hashmap, copy-on-write-array-list, and blocking queue. Let's explore an example using concurrent hashmap. In the code, a concurrent hashmap is created to store key-value pairs of string and integer. The put method adds a key-value pair to the map. The putIfAbsent method adds the pair only if the key does not already exist, preventing potential overwrites by concurrent operations. Accessing the value with get is thread-safe. Concurrent hashmap utilizes a segment locking mechanism, which allows concurrent threads to access different segments of the map for writes, thereby increasing efficiency over collections.synchronized map. Executor framework. The executor framework is a set of classes in the java.util.concurrent package that simplifies the execution of tasks in asynchronous mode. It provides a layer of abstraction over explicit thread management. Executor, executors, executor service, and scheduled executor service are key interfaces and classes in this framework. The provided code demonstrates the creation of a single-threaded executor service, submission of a simple task that prints the current thread's name, followed by an orderly shutdown of the executor. It attempts a graceful shutdown, waiting up to 5 seconds for existing tasks to complete before resorting to a forceful shutdown. Thread pools. In Java, thread pools manage a pool of worker threads, which are used to perform tasks asynchronously. Thread pools help to limit the number of threads in an application and reuse threads for multiple tasks, improving the performance by reducing overhead of thread creation, especially in high-load scenarios. The java.util.concurrent executor service interface and its implementations, like thread pool executor, provide a framework for managing and queuing tasks. The given code snippet sets up a thread pool using executor service with a fixed number of threads, 5. It then submits 10 tasks to the pool. Each task is a simple lambda expression that prints out the task ID and the name of the thread executing it. After submitting all tasks, the executor service is shut down with the shutdown method, which initiates a graceful shutdown where previously submitted tasks are executed, but no new tasks will be accepted. Locks. In Java, locks are tools for controlling access to a shared resource by multiple threads. They help prevent race conditions by ensuring that only one thread can execute a critical section at a time. The java.util.concurrent.locks.lock interface provides more sophisticated thread synchronization than the synchronized statement. Below is an example using reentrant lock. The code defines a counter class with a method increment that safely increments a count variable. A reentrant lock instance is used to ensure that the increment operation is atomic. When a thread calls increment, it acquires the lock using lock.lock. If another thread has already acquired the lock, the current thread will wait until the lock is released. The try finally block ensures the lock is always released, even if an exception is thrown, preventing deadlocks. Deadlocks and avoidance. In Java, a deadlock is a situation where 2 or more threads are blocked forever, each waiting for the other to release a lock. A common cause of a deadlock is when multiple threads need the same locks but obtain them in a different order. Deadlock avoidance involves ensuring that several conditions, like mutual exclusion, hold and wait, no preemption, and circular wait, don't occur simultaneously. The provided code shows a potential deadlock scenario. 2 methods, method 1 and method 2, are synchronized on 2 resources, resource A and resource B, but in the opposite order. If one thread enters method 1 and locks resource A, while another thread enters method 2 and locks resource B, each will wait for the other to release the resource's lock indefinitely. Avoiding deadlocks can involve ensuring that all threads acquire resource locks in the same order, thereby preventing the circular wait condition. Also, reducing the scope of synchronization and using lock timeout strategies can help prevent deadlocks. Java.util.concurrent package overview. The java.util.concurrent package provides a set of tools for managing and executing concurrent tasks in a Java application. It includes a number of useful classes for thread pool management, atomic operations, blocking queues, and a plethora of utility classes that aid in writing thread-safe concurrent code. The provided code snippet demonstrates the use of java.util.concurrent.executor service to run a simple task on a single thread. An executor service is created using the executor's factory methods, in this case, new single thread executor, which means the tasks will be executed sequentially in a single thread. The submit method is used to send a runnable task for execution, which in this example prints the current thread's name. After submitting the task, shutdown is invoked to stop accepting new tasks and shut down the executor service gracefully once all tasks have completed. Stack versus heap. In Java, memory is primarily allocated in two areas, the stack and the heap. The stack is used for execution and storing primitive types and object references, while the heap is used for storing objects. Here's an example to illustrate the use of stack and heap in Java. In the code, primitive is of a primitive type and is stored directly on the stack. The wrapper is an instance of the integer class, which means the actual object containing the value is stored on the heap, but the reference is on the stack. Likewise, object is a reference to an instance of main, with the reference on the stack and the actual object on the heap. When the method execution completes, the stack frame is popped off the stack along with its primitives and references, but the objects will remain on the heap until they're removed by the garbage collector. Garbage collection. Garbage collection in Java is the process by which the Java Virtual Machine, JVM, automatically removes objects that are no longer in use to free up memory resources. When objects are created in Java, they are stored in the heap memory, and garbage collection is primarily focused on this area. This code manually suggests to the JVM that it is a good time to start the garbage collection process. However, it doesn't force it. The garbage collector in Java is generally non-deterministic, and the call to system.gc is merely a hint, not a guarantee that it will run. If the garbage collector does run, it will look for objects that are not reachable from any references in the executing code and release their memory. Reference objects: strong, soft, weak, phantom. In Java, the way references to objects are handled can affect garbage collection and memory management. There are 4 types of references: strong, soft, weak, and phantom. Each type of reference has a different level of strength, which in turn affects how the garbage collector treats the objects they reference. In the provided code, we create instances of each type of reference. Strong references are the usual references which prevent the referred object from getting garbage collected. A soft reference object stays in memory until JVM requires memory urgently. A weak reference object can be collected once it is weakly reachable, meaning there are no strong or soft references. A phantom reference object is used for scheduling pre-mortem cleanup actions because it becomes unqueued in the provided reference queue right before the garbage collection. We then force garbage collection and sleep for a short time to let it execute, and afterwards, we check which objects are still referenced. Typically, only the strong reference would reliably remain. Memory leaks. In Java, memory leaks occur when objects are no longer being used, but the garbage collector is unable to remove them from working memory because they are still referenced. This can lead to out-of-memory errors when the JVM runs out of space to allocate new objects. Memory leaks are often subtle and can manifest over time, especially in applications that run for long periods or manage lots of resources. The provided code snippet showcases a potential memory leak. The list object, which is a static member of the memory leak example class, is populated with random numbers in the populateList method. Since it's static, the list retains its objects beyond the lifecycle of any instance of memory leak example and is not eligible for garbage collection. If the populateList method is called multiple times over the course of the application's life, the list will keep growing indefinitely. As there is no mechanism in place to clear the list, this could eventually lead to an out-of-memory error as the JVM runs out of heap space. Object creation and destruction. In Java, object creation is the process by which a new instance of a class is allocated memory on the heap and initialized. This is typically done using the new keyword followed by a call to a constructor. In this code, a new object of class dog is created using new dog buddy. This allocates memory for a new dog instance on the heap and calls its constructor to initialize the object with the name buddy. The object's bark method is then called, which outputs buddy says bark to the console. Basics of networking. In Java, a socket is one endpoint of a two-way communication link between two programs running on the network. A socket is bound to a port number so that the TCP layer can identify the application that data is destined to. Let's look at a basic example of a client socket attempting to connect to a server socket. The code above attempts to create a client socket that will connect to a server. Localhost refers to the current machine, and 1234 is the port number where the server is expected to run. The try block with resources is used to ensure that the socket is closed properly at the end of the block, avoiding resource leaks. If a connection cannot be established, or an I/O error occurs, the catch block will handle it by printing an error message. Inet address class. The inet address class in Java is a part of the java.net package, and it represents an IP address, both IPv4 and IPv6. It is used for handling networking tasks such as name resolution, which is the process of converting a domain name into its corresponding IP address. In the provided code, we import the java.net package to access the inet address class. We then have a class named inetAddressExample, with a main method that attempts to find the IP address of example.com. It uses the inetAddress.getByName method, which throws an unknown host exception if the hostname cannot be resolved. On a successful resolution, it prints out the hostname and IP address of example.com. We use a try-catch block to handle any potential unknown host exception. URL and URI. In Java networking, a URI, Uniform Resource Identifier, is a string of characters used to identify a resource either on the internet or a local network. Uniform Resource Locator is a type of URI which provides a way to locate a resource by describing its primary access mechanism and network location. Java provides classes URI and URL in the java.net package for working with these concepts. The provided code demonstrates how to create a URI object and convert it to a URL in Java. It uses the URI constructor to pass a given string representing a URI. The TURL method is then called on the URI instance to convert it to a URL object. Finally, it prints out the string representations of both the URI and the URL. Sockets and server sockets. In Java, sockets and server sockets are used for network communication. A socket is an endpoint for communication between two machines, whereas a server socket waits for requests to come in over the network. In the code, a server socket object is created to listen on port 1234. When a client requests a connection, the server accepts the connection with serversocket.accept, which returns a socket object. This socket object is then used to communicate with the client. Finally, the server socket is closed with serversocket.close. TCP/IP client and server. In Java, TCP/IP client and server communication is facilitated using socket and server socket classes. The server creates a server socket on a specific port, listens for client requests, and creates a socket once a connection is established. The client creates a socket to connect to the server. Data is read from and written to the socket using streams. UDP datagram sockets. UDP, User Datagram Protocol, is a minimal message-oriented transport layer protocol. In Java, it's represented by the datagram socket class, which can be used to send and receive datagram packets containing a data buffer, the destination address, and port for sending, or an empty buffer for receiving. This code snippet demonstrates a simple UDP sender in Java. It starts by creating a datagram socket for sending UDP packets. Then, it converts a string message into bytes, as UDP communications require byte arrays. Next, it resolves the destination IP address using inetAddress.getByName, which is localhost in this case. A datagram packet is created with the message buffer, length, destination address, and a port number. The packet is then sent through the socket with the send method. Finally, the socket is closed to release resources. Networking principles, ports, protocols. In the context of networking, a port is a virtual location where network connections start and end. Protocols are sets of rules that determine how data is transmitted and received over a network. Common protocols include HTTP for web traffic, FTP for file transfers, and TCP and UDP for different styles of data transmission. The provided Java code demonstrates a basic use of networking, where a socket object is created to establish a connection to www.example.com on port 80, which is the default port for HTTP traffic. The socket constructor takes an inet address, which represents an IP address, and an integer for the port number. The try-catch block is used to handle exceptions that might occur during network operations. After the intended data transfer operations, not shown in the snippet, it's important to close the socket to free up system resources. Introduction to JDBC. JDBC, Java Database Connectivity, is a Java API that allows Java programs to interact with databases. JDBC provides methods for querying and updating data in a database and is oriented towards relational databases. The core components of JDBC include drivers, connections, statements, and result sets. The code initiates a database connection using driver-manager.getConnection with the appropriate database URL, username, and password. A statement is created from the connection object to execute a query. The result set object stores the data retrieved by the query. Inside the while loop, we iterate over the result set and retrieve values using the getString method. After processing, resources such as result set, statement, and connection are closed to prevent resource leaks. The catch block catches and handles SQL exceptions that may occur during database operations. JDBC architecture. JDBC stands for Java Database Connectivity, which is a standard Java API for database-independent connectivity between the Java programming language and a wide range of databases. The JDBC API provides a set of interfaces and classes which Java applications use to connect to databases, execute SQL statements, and retrieve results. While the code isn't provided for the introduction, it's important to note that JDBC encompasses a set of interfaces such as connection, statement, and result set, which are implemented by driver vendors to interact with databases. These implementations are database-specific, but provide a uniform API for database access across different databases. Establishing a connection. In Java, establishing a connection to a database requires the use of the JDBC API. This involves loading the appropriate database driver, defining the connection URL, and creating a connection instance. The code imports the necessary classes from the java.sql package. It declares a main method, which is the entry point of the program. The database connection URL, username, and password are specified as string variables. The class.forName method is used to ensure that the JDBC driver is loaded. Then, driver manager's getConnection method is used to establish the connection with the provided URL, user, and password. If the connection is successful, a confirmation message is printed. Otherwise, exceptions are caught and an error trace is printed. CRUD operations using JDBC. CRUD stands for Create, Read, Update, and Delete, which are the four basic operations for managing data in a database. JDBC, Java Database Connectivity, is an API in Java that enables interaction with various types of databases. We will cover how to perform CRUD operations using JDBC. The provided code begins by importing the necessary SQL classes. It then declares a JDBC CRUD class and a main method. Inside the method, it establishes a connection to a MySQL database using a URL, username, and password. A statement object is created to execute the SQL queries. We perform the four CRUD operations: inserting a new record, create; querying the database, read; updating an existing record, update; and deleting a record, delete. After the operations, database resources like statement and connection are closed to prevent resource leaks. Exception handling is done using a try-catch block to catch SQL exceptions. Prepared statement. In Java, the prepared statement interface extends the statement interface and represents a precompiled SQL statement. This can be used to efficiently execute the same statement multiple times, providing the ability to set parameters dynamically. It helps in preventing SQL injection attacks and often results in better performance than statement objects. The code snippet creates a connection to a database, then defines a SQL insert query with placeholders for parameters. A prepared statement object is created with this query using the connection's prepareStatement method. Parameters are set using the setString method. The first argument, 1, 2, is the placeholder index, and the second argument is the actual value to set. The executeUpdate method executes the SQL insert, returning the number of rows affected. Result set. In Java, a result set is an object that represents the result set of a database query. It acts like a cursor pointing to the current row of data. When a query is executed, a result set object is returned, through which you can iterate and read the data. The provided code demonstrates the usage of a result set in Java. First, we create a statement object to execute our SQL query. We then execute a select query that retrieves all rows from table name. The executeQuery method returns a result set. We iterate over this result set using rs.next to move the cursor to the next row. For each row, we retrieve column values using appropriate getter methods like rs.getInt or rs.getString, specifying the column name or index. The retrieved values can then be processed as needed. Transactions management. Transactions in Java Database Connectivity, JDBC, allow for a group of SQL statements to be executed as a single unit of work. A transaction will either be completely successful and commit all changes to the database, or if there's an error, it will roll back any changes made to the state prior to the transaction. JDBC's connection object provides methods to handle transactions such as setAutoCommit, commit, and rollback. Connection pooling. In Java, connection pooling is a technique used to manage database connections in a pool where a set of reusable connection objects is kept ready to be used by any process that needs them. This improves the application performance by reusing existing connections rather than opening a new one every time a database interaction is required. The code defines a class ConnectionPoolExample that uses a data source object to manage a pool of database connections. The data source interface is part of the javax.sql package and is implemented by connection pooling libraries, e.g. Apache DBCP, Hikari CP, etc. The getConnection method retrieves a connection from the pool managed by the data source. If a connection is not being used, it will be provided. Otherwise, a new one is made, or a wait happens until one becomes available. This reduces overhead and increases performance. Reflection API. The Reflection API in Java is a powerful tool that allows runtime retrieval of information about classes, interfaces, fields, and methods. You can also use it to instantiate objects, invoke methods, and set field values dynamically. The code demonstrates the use of the Reflection API to print the names of all declared methods of the java.langString class. It first loads the string class into a class object using class.forName. Then, it retrieves all declared methods using getDeclared methods. Finally, it iterates over the array of methods and prints their names using getName. Note that this example may throw the checked exception classNotFound exception if the class cannot be located, which is why the main method is declared to throw exception. Annotations. Annotations are a form of metadata that provide information about the code but do not have a direct effect on the code itself. They can influence the way a program is treated by the compiler and runtime. The code defines a custom annotation called myAnnotation with a retention policy of runtime, meaning it will be available at runtime for reflection. It has two elements: value with no default, thus mandatory, and version with a default value of 1. My class is then annotated with myAnnotation, setting its value to example and overriding the version to 2. JavaBeans and the BeanInfo interface. JavaBeans are reusable software components that can be visually manipulated in builder tools. They adhere to specific conventions, including a zero-argument constructor, properties accessible via getter and setter methods, and possibly event handling methods. JavaBeans are serializable and often used in Java Enterprise Edition as components. The code provided is an example of a simple JavaBean called userProfileBean. It follows the JavaBean standards with a zero-argument constructor, private fields for properties, and public getter and setter methods for these properties. The bean is marked as serializable by implementing java.io.serializable which is a marker interface indicating objects of this class can be serialized and deserialized, maintaining state over various processes. Java Naming and Directory Interface, JNDI. Java Naming and Directory Interface, JNDI, is an API that provides naming and directory functionality to applications written in Java. It allows Java software components to locate other Java software components and data, such as objects within a directory service, such as LDAP, DNS, or RMI. JNDI is designed to be independent of any specific directory service implementation. Thus, a variety of services can be accessed in a uniform way within the Java application. The provided code snippet demonstrates how to use the JNDI API to look up an object stored in the JNDI directory. An initial context object is created, representing the starting context for name and directory operations. Through this context, we perform a lookup using a name, which can be likened to a path in a file system. The object associated with the name is retrieved and cast to the expected type, in this case, a string. Finally, the retrieved data is printed to the console. Proper exception handling is essential to deal with any issues during the lookup process. Java Message Service, JMS. Java Message Service, JMS, is a Java API that allows applications to create, send, receive, and read messages. It's designed to provide a common way for Java applications to create, send, and receive message data across different messaging systems and protocols. Java Server Pages, JSP, and Servlets. Java Server Pages, JSP, and Servlets are server-side Java technologies for building web applications. JSP allows embedding Java code directly into HTML pages, while servlets are Java programs that extend the capabilities of servers hosting applications accessed by means of a request-response programming model. We don't need code to understand the basic concept of JSP and servlets. Servlets act as a controller to handle client requests and process them to generate a response, often in conjunction with JSP, which acts as a view to present the application's user interface. This separation of logic and presentation facilitates easier application development and maintenance. JavaFX for GUI. JavaFX is a set of graphics and media packages that enables developers to design, create, test, and deploy rich client applications that operate consistently across diverse platforms. Let's start with a simple JavaFX application that opens a window with a button saying Hello World. The provided code is a basic JavaFX application. It imports the necessary JavaFX classes for the application window and UI elements. The Hello World class extends application, a base class from JavaFX. The start method is overridden to set up the UI, a button is created, and an event listener is added to print Hello World when the button is clicked. The UI is added to a stack pane, which is a layout container, and then wrapped in a scene that is set on the primary stage, the main window. The main method calls launch args to start the JavaFX application lifecycle. Java Web Start. Java Web Start is a framework developed by Sun Microsystems that allows users to start application software for the Java platform directly from the internet using a web browser. While Java Web Start has been deprecated and its support was removed in Java 11, it's worth understanding for historical context. It functioned using Java Network Launch Protocol, JNLP files to provide the necessary information to launch Java applications. The protocol ensured that the latest version of the application was downloaded and cached locally, allowing for updates to be automatically applied. It also provided security features and integration with the desktop environment. To launch a Java application using Java Web Start, users simply clicked a link on a website. Lambda expressions. Lambda expressions are a feature in Java that enable you to treat functionality as a method argument or code as data. They are similar to methods but do not need a name and can be implemented right in the body of a method using a simple, concise syntax. They can be passed around as if they were an object and execute on demand. In this code snippet, forEach is a method that takes a lambda expression as an argument. The lambda expression n, system.out.println n, is executed for each element in the list. Here n represents the parameter passed to the lambda expression, which is the current item in the list. The manus operator separates the parameters from the body of the lambda expression. The body of this lambda is a single statement that prints out the value of n. Stream API. The Stream API in Java was introduced in Java 8 and represents a sequence of elements on which one can perform various operations. These operations can be either intermediate, transforming a Java stream into another stream, such as map or filter, or terminal, producing a result or a side effect, such as count or for each. Streams are designed to provide a high level of abstraction for dealing with sequences of data, allowing for expressive and efficient data processing. In this example, a list of integers named numbers is created containing elements from 1 to 10. A stream is created from this list using the .stream method. The stream is then piped into a filter operation, which removes any elements that are not less than 5. Finally, the result of the filter is collected into a new list, which is then printed to the console. This example demonstrates a simple stream operation using filter and collect. Apache Maven. Apache Maven is a software project management and comprehension tool. Based on the concept of a project object model, POM, Maven can manage a project's build, reporting, and documentation from a central piece of information. The code snippet is a basic structure of a Maven pom.xml file, which is at the heart of a Maven project. The model version denotes which version of the project object model is being used. Group ID is the identifier of the project's group. Artifact ID is the unique ID for the project's artifact, name of the jar or WAR file, and version indicates the version of the artifact. This configuration file is used to define the project along with its dependencies, build directory, source directory, test source directory, and goals, among other settings. Apache Ant. Apache Ant is a Java-based build tool that uses XML to describe the build process and its dependencies. Unlike Make, which uses Makefile, Ant uses XML files called build.xml. It is used for automating build processes and is particularly good for Java projects. This basic build.xml snippet defines a project named Hello World and sets its default target to compile. Inside the compile target, it first prints a message indicating it is compiling sources. Then, it compiles Java source files from the src directory and places the compiled bytecode in the build directory using the Java say task. The echo task is used to print messages. Gradle. Gradle is an open-source build automation system that focuses on flexibility and performance. Gradle scripts are written in Groovy or Kotlin and are designed to handle projects of any size efficiently. It's widely used for developing Java applications among other languages, platforms. The provided code is a basic build Gradle script for a Java project using Gradle. Here, the plugins block declares the Java plugin, which adds capabilities for compiling and testing Java code. The repositories block specifies Maven Central as the location where Gradle should look for its dependencies, like third-party libraries. Finally, the dependencies block declares an external library dependency, adding Google Guava to the project. These are basic elements of a Gradle build script, providing the groundwork for building and managing a Java project. Understanding build.gradle. In the context of Java development, Gradle is a popular open-source build automation tool that uses a Groovy-based domain-specific language, DSL, for declaring project settings. The build.gradle file is the script that drives the build process for a project using Gradle. It allows developers to define a project structure, dependencies, tasks, and much more. The code snippet provided defines a simple Gradle build script. The apply plugin, Java, line applies the Java plugin, which adds tasks like compile and test to the project. The repositories block declares that dependencies should be resolved from the Maven Central repository. Inside the dependencies block, two dependencies are declared, an implementation dependency on Apache Commons Math library, and a test implementation dependency on Junit for testing. Finally, a custom task is defined with the name custom task, which when executed will print "this is a custom task" to the console. Using Git with Java projects. Git is a distributed version control system that helps you track changes in your codebase. This is essential in collaborative environments, but also beneficial for individual developers. When working on Java projects, Git can be used to manage source code history, branches for features, and version tagging for releases. The git init command initializes a new Git repository and begins tracking an existing directory. It adds a hidden subfolder within the existing directory that houses the internal data structure required for version control. This is typically the first command you run in a new project directory. Branching and merging. Branching in version control systems like Git lets developers create an isolated environment in their repository represented by a branch. Every branch is like a new working directory, staging area, and project history. It allows multiple streams of work that can be separate from each other, often used for new features or bug fixes. Merging is the process of integrating changes from one branch into another, typically the main branch after the work is complete. The code snippet demonstrates the commands for branching and merging using Git. Git branch creates a new branch named feature branch. Git checkout switches to this branch. Changes are then made to the files, followed by git add to stage those changes, and git commit to commit them with a message. To integrate these changes into the main branch, you git checkout back to main, and use git merge to merge feature branch into main. Finally, git branch d deletes feature branch after the merge is successful, and the feature is no longer needed in its own branch. Version control best practices. Version control systems are essential for managing changes to source code over time. Here, we'll discuss some best practices to follow when using version control systems like Git. The provided code demonstrates a git commit command with a clear and concise commit message. Best practice includes writing meaningful commit messages that accurately describe the changes and their purpose. This helps in understanding the project history and tracking changes. Introduction to testing. Testing in Java is a crucial component of software development that aims to check the correctness, functionality, and performance of code. Introduction to testing covers the importance of testing, the types of tests, and the basics of how tests are written and run. Without code examples, this topic emphasizes the conceptual groundwork. It discusses the rationale behind testing, catching bugs early, preventing regressions, and ensuring that new changes meet expectations. Introduction to testing often covers unit testing, integration testing, system testing, and acceptance testing, although specific methodologies and practices can vary widely. JUnit framework. JUnit is an open-source framework used for the purpose of writing and running tests in the Java programming language. It is an essential tool for practicing test-driven development, TDD. JUnit provides annotations to identify test methods and expected results. This topic does not require code, as it's a conceptual introduction. JUnit helps ensure that code changes do not break existing functionality. It supports creating repeatable tests that automatically check the validity of the code functions. Developers write test cases that call methods and check for expected outcomes. Test cases, test suites. In Java, a test case is a class where we test the functionalities of methods to ensure they produce expected results. These are often annotated with @test and can be created using testing frameworks like JUnit. In the given code snippet, a class named calculatorTest contains a test case test_add. It uses JUnit 5's @test annotation to denote a test method. Inside this method, the calculator object's add method is tested by using assert equals to assert that the sum of 2 and 3 is indeed 5. The string at the end of assert equals serves as an optional failure message if the test fails. Assertions. Assertions in Java are used to assert a condition during testing and development, which should be true for the program to continue running. They are intended as a means to detect programming errors, testing assumptions in code. An assertion error is thrown if the expression evaluates to false. In the provided code, assert is the keyword used to introduce the assertion statement. The condition value equals 0 is what we are asserting to be true. If it evaluates to false, an assertion error with the message value must be non-negative will be thrown. This checks that the variable value is non-negative during execution. Note that assertions are typically enabled during testing and disabled in a production environment. Mockito for mocking. Mockito is a popular mocking framework used in Java to create and configure mock objects for unit testing. Mock objects mimic the behavior of real objects without the overhead of their actual functionality. This is particularly useful when you want to isolate the component you are testing from its dependencies. In this code snippet, we create a mock list object using Mockito. The when statement specifies that when the getZero method is called on the mocked list, it should return first element. Upon calling mockedList.getZero, it prints the string first element as specified by the stub. Finally, verifiedList.getZero checks if the getZero method was called on the mocked list, ensuring the mock's usage matches expectations. Testing best practices. Testing can be performed at various levels ranging from individual units to the entire application. Each level has specific roles in the overall testing strategy. Unit tests check the smallest parts of an application, like methods and classes. Integration tests verify that different modules or services used by your application work well together. System tests examine the entire system's behavior, and acceptance tests evaluate the system's compliance with the business requirements. Testing at different levels ensures that issues are caught early and the system is examined comprehensively. Understanding design patterns. In software engineering, design patterns are typical solutions to common problems in software design. They represent best practices used by experienced developers and are useful for efficient problem solving. Design patterns can be categorized into three types: creational, structural, and behavioral. Creational patterns provide object creation mechanisms. Structural patterns explain how to assemble objects and classes into larger structures, while behavioral patterns define the communication between objects. They don't provide immediate code solutions, but offer templates for addressing various design challenges. Creational patterns: singleton, factory, abstract factory, builder, prototype. The singleton pattern ensures a class has only one instance and provides a global point of access to it. The code defines a class singleton with a private constructor to prevent instantiation from outside the class. It has a private static field instance to hold the single instance, and a public static method, getInstance, that creates the instance if it doesn't already exist, then returns it. Structural patterns: adapter, composite, proxy, flyweight, facade, bridge. The adapter pattern allows incompatible interfaces to work together. This pattern involves a single class, known as the adapter, which joins the functionality of an independent or incompatible interface to another. In the code, we have an adapter class that implements the target interface. The adapter contains a reference to adaptee and overrides the request method to call adaptee's specific request. This allows an instance of adaptee to satisfy requests through target interface indirectly. Behavioral patterns: command, observer, strategy, template method, iterator. The command pattern encapsulates a request as an object, allowing for parameterization of clients with queues, requests, and operations. It also allows for the support of undoable operations. This code defines a simple command pattern. An interface command declares an execute method. The lightOnCommand class implements command and encapsulates the action of turning on the light. The light class represents a receiver with on and off methods. Lastly, remote control acts as an invoker that can be given any command and can execute it when the button is pressed. Concurrency patterns: thread pool, worker thread. A thread pool is a concurrency design pattern that manages a set of pre-initialized threads, which can be used to execute tasks. This pattern improves performance and resource management by reusing threads for multiple tasks, thus reducing the overhead of thread creation, especially in applications with a high number of concurrent short-lived tasks. The provided code sets up a fixed-size thread pool with 4 threads using executors.newFixedThreadPool4. Runnable tasks are created within a for loop, and each task is executed using executor.executeWorker. The call to executor.shutdown initiates an orderly shutdown in which previously submitted tasks are executed, but no new tasks will be accepted. We then wait for all tasks to finish with a while loop checking executor.isTerminated before printing out a message indicating that all threads have finished execution. Architectural patterns: MVC, MVVM. The MVC pattern is a way to separate concerns in a software application. The model represents the data or business logic, the view is the presentation layer, and the controller manages interactions between the model and the view. In this code, the user controller acts as the controller that coordinates the flow between the user model, and the user view, the view. When update user view is called, it retrieves data from the model and then tells the view to present this data, separating the way data is obtained from the way it is displayed. Creating runnable jar files. A jar, Java archive file, allows you to efficiently deploy Java applications by packaging the .class files and associated metadata and resources into a single compressed file. Runnable jar files are those that contain all the necessary components to run an application, including the entry point method, main method, specified in its manifest. The code shown is an example of a manifest.mf file, which is necessary for creating a runnable jar file. It states the version of the manifest, class path, and specifies the main class entry point of the application. In this case, com.example.main_app is the fully qualified name of the class containing the public static void main string args method. Including this manifest.mf in your jar tells the Java runtime which class to execute when the jar is run. Logging with Log4j. Log4j is a reliable, fast, and flexible logging framework, API, written in Java, which is distributed under the Apache software license. Log4j has been around for several years and has gained widespread adoption. Logging is crucial for understanding the flow of a program and for debugging purposes. Log4j allows developers to log at various verbosity levels, such as debug, info, warn, error, and fatal. This code snippet demonstrates the use of Log4j for logging information and error messages within a Java application. The logger instance is created by calling logger.getLogger demoapp.class, which associates the logger with the demoapp class. Inside the main method, logger.info and logger.error are used to log messages at the info and error levels, respectively. Upon execution, these messages are outputted to the configured appender, which could be the console, a file, or other destinations as set up in the Log4j configuration. Java Application Monitoring. Java Application Monitoring is a critical facet of system maintenance, allowing developers to track the performance and health of their applications in real time. Monitoring can identify bottlenecks, detect failures, and provide metrics that can be used to optimize system performance. Tools like JConsole and Visual VM, along with APIs such as Java Management Extensions, JMX, facilitate such monitoring. The provided code snippet demonstrates a basic form of Java application monitoring, where the memory usage of the application is being calculated and displayed. The runtime class in Java is used to interact with the JVM runtime environment. The total memory method returns the total amount of memory in the JVM, while free memory returns the amount of free memory. By subtracting the free memory from the total, we get the memory currently used by the Java application. This simplistic example provides a quick snapshot, but real-world monitoring would be far more complex, using JMX or other monitoring tools. Java Mission Control. Java Mission Control, JMC, is a powerful profiling and diagnostics tool integrated into the JDK. It is used to gather detailed low-level information about how the Java Virtual Machine, JVM, and Java applications are running. You can monitor live applications, collect detailed performance data, and perform advanced troubleshooting without significant overhead. JMC doesn't have a direct code example since it's a tool that comes with the JDK. You can start it by running JMC from the command line if you have the JDK installed. Once started, it provides a user interface that allows you to connect to running Java applications and collect data on their performance, such as CPU usage, memory allocation, and thread activity. You can use it to detect memory leaks, identify performance bottlenecks, and get insights into the behavior of your application under various conditions. Troubleshooting JVM issues. Troubleshooting issues within the Java Virtual Machine JVM is an essential skill for maintaining a healthy Java application. From performance bottlenecks to memory leaks, the JVM can encounter various problems that may hinder application performance or cause crashes. The JMap tool generates memory maps for Java processes. The option nash histo live prints a histogram of the heap and shows the number of instances and the amount of memory each Java class is using. The PID is the process ID of the Java application you want to inspect. The head command simply limits the output to the first few lines for better readability. This command is useful to identify memory leaks by showing classes that are using disproportionately high amounts of memory. Performance tuning. Performance tuning in Java involves optimizing code and resource management to improve application performance. Factors such as memory usage, execution speed, and threading can heavily influence the efficiency of a Java program. The goal is to ensure that the application runs smoothly, responds quickly to user input, and uses system resources optimally. The provided code snippet illustrates a simple way to measure the memory usage of a particular section of a Java program. The runtime object is used to obtain the total memory in the JVM and the free memory available. By calculating the difference before and after the execution of some code, we can determine the amount of memory used by that code section. This is a basic example of how one might start identifying parts of code that could be targeted for memory optimization. Documentation with JavaDoc. JavaDoc is a tool used for generating API documentation in HTML format from doc comments in the source code. It is widely used because it enables developers to create documentation that is easy to read and maintain. In the code provided, JavaDoc comments are used to describe the purpose of the Hello World class and the main method. The class-level comment gives a brief description of what the class does. The method-level comment explains the main method, including a description of its parameter. When processed by JavaDoc, this would generate an HTML page with the documented API. Overview of Spring Framework. The Spring Framework is an open-source application framework that provides comprehensive infrastructure support for developing Java applications. At its core, Spring manages the life cycle of beans, which are the objects that form the backbone of your application. It facilitates dependency injection, DI, aspect-oriented programming, data access, transaction management, and more. While we cannot represent the entire Spring framework with a snippet of code due to its vast ecosystem, the following is a conceptual illustration of a simple Spring bean configured with annotations. Introduction to Hibernate ORM. Hibernate ORM, Object Relational Mapping, is a Java framework that simplifies the development of Java applications to interact with databases. It is an implementation of the Java Persistence API, JPA, which allows you to map Java classes to database tables and convert Java data types to SQL data types and vice versa. The provided code snippet demonstrates a basic Hibernate usage pattern. First, it opens a Hibernate session from the session factory, which represents a configuration of the database and entity mappings. Then it starts a transaction, which is necessary for encapsulating a sequence of operations as a single unit of work. Within the try block, you can perform CRUD operations such as saving or retrieving entities. After the operations complete, the transaction is committed to apply the changes to the database. If an error occurs during the transaction, it is rolled back to maintain data integrity. Finally, the session is closed. Java Server Faces JSF. Java Server Faces JSF is a Java specification for building component-based user interfaces for web applications. It provides a standard approach for UI development in Java EE environments. JSF is event-driven, server-side, component-based, and follows the Model View Controller (MVC) design pattern. In this code snippet, @managedBean is an annotation that marks a bean to be managed by the JSF framework. It allows the framework to control the bean creation, dependency injection, and scope management. Beans in JSF can be used to hold data and execute logic when interacting with the UI components of a JSF application. RESTful Web Services with JAX-RS. JAX-RS is a Java API for developing RESTful web services. It uses annotations to simplify the development and deployment of web service clients and endpoints. Here we will create a simple RESTful service using JAX-RS that responds to HTTP GET requests. SOAP Web Services with JAX-WS. SOAP, Simple Object Access Protocol, is a protocol for exchanging structured information in the implementation of web services using XML. JAX-WS, Java API Web Services, is a framework that simplifies the task of creating SOAP web services in Java. It provides annotations to define web service endpoints and their operations. Below is a simple JAX-WS example that defines a web service endpoint with one operation, say hello, that returns a hello message. The code snippet defines a JAX-WS web service using the web service annotation. It has a single method sayHello annotated with web method, which signifies it's a service operation. The method takes a string name as a parameter and returns a greeting message. When this service is deployed on a server, clients can invoke this operation using SOAP requests, and the server will respond with a SOAP message containing the greeting. Testing with Junit and TestNG. Junit is a popular unit testing framework in Java. It allows developers to write and run tests, which help ensure that code behaves as expected. A basic Junit test is annotated with a test and contains assertions to verify tested behavior. Integration with front-end technologies. In modern web application development, separating the front-end and back-end layers is a common practice. This separation allows developers to build scalable and maintainable codebases. Java frameworks often serve the back-end logic, the server side, and interact with front-end technologies like HTML, CSS, and JavaScript, the client side. One way this integration is achieved is through RESTful APIs, which expose HTTP endpoints for the front-end to consume. In the provided Spring Boot example, we have a simple REST controller named front-end controller. It has a method getMessage annotated with @getMapping, which means it responds to HTTP GET requests at the /API message URL. When this URL is accessed, it returns a plain text message. A front-end application can make an HTTP GET request to this URL to retrieve the message and display it to users, thus achieving integration between Java backend and any front-end technology capable of making HTTP requests. Security with Spring Security. Spring Security is a powerful and highly customizable authentication and access control framework for Spring applications. It is the de facto standard for securing Spring-based applications. Spring Security provides comprehensive security services for J2EE-based enterprise software applications. The code snippet above defines a basic security configuration using Spring Security. The @enable web security annotation marks the class as a configuration that defines security filters. The class extends Web Security Configurer Adapter, providing a convenient base class for creating a Web Security Configurer instance. The Configure HTTP Security HTTP method defines which URL paths should be secure. In this example, the root, and home paths are configured to be accessible to everyone. All other paths require authentication. The code snippet also configures a custom login page and enables all users to access it, permit all. Additionally, it enables a logout functionality for all users.